Hello, all welcome to my YouTube channel. Another video. In this video, I'm going to talk about counting sort. We will discuss complete algorithm, how it works, containing all these steps, and I will also provide you one example to make you understand better. So, without wasting any time, let's get started. So, counting sort is a non-comparison based sorting algorithm. So, basically, we have other algorithms like merge sort, insertion sort, quick sort, etc., in which we use comparison to compare the elements and then decide which or element should appear first and which appear should appear at the end according to the order for the sorting. But in this algorithm we use different approach. So let's see how it works. So it works when values are in range 0 to k, where k is the maximum element. We use counting plus prefix sum to make this algorithm work. So let's see. Let's move to the next slide. So at the first step, we will create two arrays. First array is B array, that is 1 to n, and second array is 0 to k, where n is the number of elements. Let's say if we are having 7 elements, then it will be B will range from 1 to 7, and let's say the maximum element is 8, then C will range from 0 to 8. So that was first step. The second step is initialize all. Ci is equal to 0. Then we will initialize the C array with 0 elements. So the value of all the elements are currently 0. Third step, we will count the frequency of elements. And fourth step, we will compute prefix sum in C. So I will explain you both these steps when we will reach there in detail. Fifth step, we will build output array. I will also explain how we are building output array, why we are building it from right to left. So I will also explain you associated conditions as well. And at the end, we are returning sorted array. So let's move. So first, we are initializing, as discussed before, we are initializing A and B. Uh, we are initializing B and C. A is already initialized. A is input array. B is the output array. Count array is C. And we are setting all the elements of C to 0. Let's say, example, we are having this array 4228331. So n is 7 as number of elements are 7. And k is 8 because 8 is the maximum element in the array. Now we will count the frequency. So we will traverse A from left to right. For each element, we are appending it, adding 1 to every element. We are doing summation and we are adding 1 for each element. Let's see how it works, how frequency is being counted. So let's say 0 is coming 0 time, then it is 0, and 1 is coming 1 time, that is 1, and at the next we see that we are having 2, that means number 2 is coming twice, that's why it is 2. And then we are seeing 2, that means number 3 is coming twice, that is why it is 2. And then we see number 4 is coming once, then that's why it is 1. And at the end we see 1, that means number 8 is coming once, then we are setting it to 1. So let me show it how more clarity. So we can see in this array, in A array, 1 is coming once, 2 is coming twice, 3 is coming twice, 4 is coming once, and 8 is coming once. So that is how we have done it. So we have counted the frequency. I hope this step is clear now. And the next is the prefix sum. So this is the most crucial step in this algorithm. So what we are doing is we are adding the all the previous values, and it will show how many elements are less than that previous value or the current value. So it is more like cumulative frequency thing we do in statistics. if you're familiar with that. But if you're not familiar, that is also fine. We will go through it. So it gives final positions. So Ci is elements is less than I, and prefix result comes like 0, 1, 3, 5, and then after that we are having 4 times 6, and then we are having 7. So what does it mean? So first is 0. 0 means that there are 0 elements that are less than 0. So we see here that C is 0, and if we add 1 to it, then it will become 1, and if we add 1 to 2, it will become 3, and if we add 3 to that 2, then it will become 5, and if we add 1 to 5, then it will become 6, and then if we add 0 to 6, it will be 6, and if we add 0 to 6, it will again be 6, and if we add 0 to 6, it will again be 6, and if we add 1 to 6, it will be 7. So that is how it is being calculated. We are taking the sum from the starting, like 0 plus 1 plus 2 plus 2 plus 1 plus 0 plus 0 plus 0 plus 1, like that. So that is how we are calculating the prefix sum, and at the end we get this output. C will be like this, where last value is total elements. So 7 we see is the value, and 7 is the number of elements in this input array A. If you see the C, it is having 9 elements, but in the input array we are having only 7 elements. So let's move to the next step. Yeah, in the next step, we are just elaborating how we are making use of prefix sum. So C is 2 equal to 3 means last position of 2. C3 equal to 5 means last position of 3. And position are 1 based. And in the next step, we will build the output array. So before building the output array, let's make this thing clear. So C2 equal to 3 means last position of 2. If we see this element at index 2, that is 0, 1, 2, that is 3. So we see that C2 is equal to 3. It means that last position of 2 is C. And if we see uh, C of 3 is 5. If we see 0, 1, 0, 1, 2, 3, it is 5. Like this, it is 5. It means the last position of 3. That is how it is being calculated. And positions are 1 based. So let's build output array. Also in this, what does it means position are 1 based? It means that the position can appear twice as well, but positions are like this. If it is C3 equal to 5, that means there are uh, like this much 3 elements less than 3, like this. Like this we are doing it. So now we will build the output array. So we will traverse the input array A from right to left. Why we are traversing from right to left? We are doing it to make it stable sort. Why? Because let's say there were 2 times 2 that is coming in the array. 1, 2, 2, 3. Then 2 is coming twice. So we want to make sure that the 2 that is coming at uh, that is first true. That means that the true that is coming first or previously will remain to the left. So that is why we are traversing from right to left, and then we will place the element b of c of value, that is aj. I will show you the full algorithm in the next step, and then we decrease the value by 1 and keep iterating and traversing the array to build the output. So Why right to left? Because it ensures stability, it preserves the order of duplicates. As I've mentioned before, like if we are having two twice, that means that first two is coming at first position and second two is coming at second position. And move to the next step. So in the next step, array is sorted like this. Now I'll show you the full algorithm. So full algorithm looks like this. Like we are initializing the arrays, then we are setting the value to 0, then we are counting the frequency, then we are doing the prefix in the 8th step. We see that ci is equal to ci plus ci plus, and ci now contains the elements less than or equal to I. As I mentioned earlier, that uh, l- uh, let's say if I is 5, that means ci is having all the elements that are less than 5, and it will show us the number of elements that are less than 5. So that is how it works. This step is the most crucial steps. That's why I am emphasizing on this step, this prefix sum step. And next we are copying the array, and by doing copying, we are traversing from right to left to preserve stability. So how we are doing it? B of C of AJ equal to AJ. AJ is the input of the original array, and we are traversing it like that. And now let's talk about the time and space complexity. So the time complexity is, as I have discussed uh, earlier, that comparison sorts are having a time complexity of n log n, and in this, the space complexity is big of n of k, and time complexity is also the same. But in case of comparison sorts, the time and space complexity can vary. Space complexity can be of or big of 1 as well, but the time complexity is always not optimized further than big of log n and log n. So that is the best we can do in comparison sort. That is the beauty of this counting sort algorithms. It is stable sorting algorithms. That means it is preserves the order of the duplicates. So when we will use this algorithm, so we will use this algorithm when a small value range is given and we are having large input size. Let's say the value is only like 0 to 10, and we are having multiple records, then we will use this algorithm. And when stability is needed, we will use this algorithm. So that is it for this video. I hope you have understood the concept of counting sort. So thanks for watching this video.